In this problem, we want to find the critical value for a two-tailed test where alpha is equal to 0.01. And we're only going to be finding critical z values. We don't have to worry about finding critical t values. So in order to do this, what I'm going to do is, first I just sketch my normal curve. I like to sketch it. I think it makes it easier to understand. It's not really necessary to sketch every time you do a problem. And we're doing a two-tailed test. And what that tells me is that we're going to have area in both tails, both the left and right tails. So now this area in the tail, and this is what we would refer to as the rejection region when we're using the classical method of doing a hypothesis test. So this area in the tail is alpha. And since we have area in two tails, we have to take the alpha that we're given, which is 0.01, and divide it by 2. So we only do that in the case of a two-tailed test. We divide alpha by 2, and I get 0.005. And so that is the area in each tail. 0.005 here, and 0.005 in the right-hand tail. So in the case of a two-tailed test, we're actually looking for two critical values. We want to know what value separates the bottom 0.005 from the rest of the graph, and then we want to know what value separates the top 0.005 from the rest of the graph. And these numbers will be the same in value. They're just going to be one positive and one negative. So in order to calculate this, what I'm going to type into the calculator is inverse norm, or INV norm, and it'll open with a parenthesis, and I'm going to find the bottom value first, so I'm going to just type in 0.005. And let me undo that. If you have the stat wizard, you're going to use 0 for the mean, mu, and 1 for the standard deviation. But if you don't have a stat wizard, or you say, what's a stat wizard? Don't worry about it. You don't have it. So you just need the 0.005. And when we put that in, we get negative 2.58, and that's rounded to 2 decimal places. So we'll always round those critical values to 2 decimal places. So now that's the value. Let's see, make a space for it. That goes right here. Now it's not necessary to actually calculate the other value because it's just going to be positive 2.58. So my final answer is plus or minus 2.58 for that problem. So it's a two-tailed test. I need two answers, one positive and one negative. Now let's look at the next problem, or number 9. And here we're doing a right-tailed test where alpha is equal to 0.01. So again, I'm going to draw my distribution. And my alpha value is only on the right-hand side. So I draw that right tail, and here's my rejection region. So this area is alpha. And since it's all in one tail, it's really straightforward. It's just 0.01. So now when I use the inverse norm function, and I should mention, to get inverse norm, you're going to press second and vars. And of course we did this in the previous chapter as well. Let's see, so inverse norm, and then it's just 0.01. Technically you should put in the area on the left hand side, and that would be 0.99. So I find that by taking 1 minus 0.01, and we get 0.99. But the reason why I just went ahead and put in 0.01, and I typed that into the calculator, and I get negative 0.233 rounded. That's not my answer. The problem is that I'm doing a right tail test. This is the answer you would use with a left tail test. But I can go ahead and just say, well, the value for the right tail test would be positive 2.33. So we have that right here. 2.33 is the value here. So I could have typed in inverse norm of 0.99, and that would have given me a positive 2.33. So either way you approach it, it's fine, because the only difference will be the sign, whether it's supposed to be positive or negative. So in a right tail test, you always get a positive critical value. In a left tail test, you always get a negative critical value, and in a two-tail test, you get one of both. So now let's take a look at number 11. Oops. And that's a left tail test where alpha is equal to 0.02. Okay, so left tail test, alpha is 0.02, and I'm not really trying to be careful about making alpha look like the actual value it is, right? So this is obviously more than 2% of the graph, and that's okay. We just want the general idea of which side it's on. So we have 0.02, so now when I do inverse norm, it's the inverse norm of 0.02, and I'm actually doing the right thing right now, and I get negative 2.05, and that's the correct answer because it's a left tail test, so we should have a negative critical value. And that's how you find critical values.